This short video has been produced to help with questions that may appear in the Scottish Qualification Authority's exam for the Higher Physics course. This time we're looking at the Particles and Waves section of the course, and specifically on the forces on charged particles. So here we have the question: a helium ion, which is a 2+ ion, undergoes acceleration between two metal plates by an electric field as shown. Using the charge on an electron in coulombs, calculate the potential difference between the plates when the kinetic energy gained by the particle is 7.5 times 10 to the minus 16 joules. And then we have a choice of potentials to choose from between A and E. So how do we go about this? Well, we need to read the question closely and pick out the things we're being asked about. We're being asked to find the potential difference, so that would be a voltage, and we can see that there is an energy provided in joules, and we are being instructed to use the charge on an electron in coulombs. So we've got coulombs, energy in joules, and we need to find a voltage. So that gives us a hint of where we're going. Look at the options, see if there's anything obvious we can ignore. Nothing obvious. Recall that this is what part of the course that this is in, so we don't get confused. Read the question again, just inside your brain, so that you can absorb what it's asking and avoid overcomplicating again. If you get lost in the question or you start bringing in too many factors and it starts to get complicated, just stop, scratch your brain clean and start again. So what are we looking at here? Well, we have an energy, which is a work, and we aren't sure what the charge is. Charge is Q, and we're trying to find the voltage, the potential difference. So here we know we have a helium ion which has a 2+ charge. So that's also known as an alpha particle. We know that the charge on a proton is equal to the charge on an electron, but the electron is negative, so it has a negative sign, but a proton is positive, so we'll have a positive sign. You'll notice on the data sheet the phrase used is the magnitude of the charge on an electron, which means it's a scalar value, so they're presenting it in the positive form on the sheet. But we had an ion with 2+, not just 1+, so we will need to take twice the charge of a proton. So we need to multiply that by 2. So now we have a value in joules, we have a value for charge in coulombs, and we're looking for the energy. Excuse me, and from the data sheet we know that there is an equation that can do that. It is W equals QV, or work equals charge times potential difference. So we can now go ahead. So we could go ahead and figure this out. We know that we can just check the equation sheet in the exam and we'll find W equals QV. You may have written that as E sub W instead of just W. Both are the same. We're looking at the energy there. Q is the charge, we've got that already, and we're trying to calculate V. So we need to jiggle the equation a little bit to find V, so that's the work over the charge equals potential difference. And we just need to plug those values in, and then we find our answer is in fact A. So that was a fairly easy way of getting there. So key things to note here are, again, identifying the variables and the units required for the answer. After the units are key to what you need to do. You can look at them, see it's a V, and know that you're looking for something with volts in it. If you're faced with something you don't know or don't recognize, like the helium ion, remember you won't be presented with anything brand new in the exam, so it must be something that you've already learned about or could work out. Here the key was the 2+ as the charge, and that the charge was measured in coulombs, and knowing that an electron and a proton have the same charge but with opposite signage. And also spotting that if something refers to a magnitude, then it will be giving it to you in the positive form, like on your data sheet for the charge on the electron. Remember to do the interim calculations, like the multiplication of the charge by 2, before you do the main calculation. It just saves you getting lost in the final calculation. As usual, here are some more examples to try. They are available on the Hi page, hy.page/physics FYSX. And thank you for watching, and see you in the next video.